Hello class, these are our notes for Algebra 1. Today's sections are 512 and 513. We are reasoning about exponential graphs. So a lot of this is going to seem like review today. So we want to go back and look at our kind of basic form for an exponential function and really think about what a and b are. So the value of a, we've been kind of calling it the starting value. And that's because it's really a y-intercept. It is our value when our x is equal to 0. So it's 0 comma a. So at the beginning, at time 0, a is like our value that we start with. The value of b is our growth factor. If it is less than 1, it's a decay factor. So if 0, it can't be negative either. So if 0 is less than b is less than 1, so if b is between 0 and 1, it's actually going to be decay. Because it's a less than 1, we're going to keep multiplying by something less than 1 and keep getting smaller. If b is greater than 1, we're looking at growth. So you could call it a growth factor or a decay factor, or you can just call it growth factor all the time. But we have to think about what we're having for those values of b and what's happening. And it's also really a multiplier. So it's what we keep multiplying by to find the value. So we take our starting value and you're multiplying by that growth factor. That's why we're calling it a multiplier, to get like what happens next. So graphs can help us see, so I'm looking down here now. A graph can help us see how the starting population 5,000 and growth factor influence the population. So you're going to notice that all three of these equations have the same starting population. They have the same y-intercept. So all three graphs start at right here at 0 comma 5,000. So all three of them start at 5,000. But the graph of blank grows more slowly than the graph of Q, while the graph of blank grows more quickly. So here's Q kind of in the middle. So which one's growing more slowly? That would be R. And which one's growing more quickly? That would be P. So, and I can tell that P is going more quickly because it's going up faster, right? That's what we're really looking at. This makes sense because the population, or maybe it should be a population, that doubles every hour is growing more quickly than one that increases by a factor of blank each hour, and both grow more quickly than a population that increases by a factor of blank each hour. So let's go ahead and compare those growth factors. So the fastest one is going to have that growth factor of 2, that's the biggest, and then the middle one would be a 1.5, and then the slowest growing is 1.2. So the one with the smallest growth factor is the one that's growing the most slowly. So we'll go ahead and fit those in. At the bottom of the page, notes are pretty short today. We are looking at an exponential function once again and trying to write our equation. So our starting value is our y-intercept, so that's going to be 0 comma 500. So we're going to use the 500 here. And then what's happening? Are we multiplying by 2? Are we multiplying by 4? What's happening to get to one value to the next? So sometimes you can just tell, like if it's 200 and then 400, we're doubling. It's hard to see on this one. So in that case, what we do is we take those y values and we create a ratio. So the second y value is the 300, and then the one before that is 500. So we get 3/5. Or you could use a decimal. If you do 3 divided by 5 on a calculator, it will give you 0.6. So either one of those is fine. So let's go ahead and write this in function form. F of x equals our starting value times our growth factor. And again, you could use the 3/5 or the 0.6. We don't care. Raised to the x power. So this is it for our notes today. Just kind of review, thinking about what our y-intercepts or starting values and our growth factor really mean, and kind of being able to identify those on a graph now as well. So as always, if you need help, please make sure you ask.